Hello, this is Miss Plant's video in which I'm going to attempt to explain forces and braking for the AQA Combined Science Physics GCSE specification, Combined Science and Physics, in 5 minutes. So the whole point of this little bit of material you need to understand is how do cars come safely to a stop. So you have your car, and then imagine you're traveling along in your car, and then all of a sudden a little bunny pops up. It doesn't have to be a bunny, it could be a boy or a tree falling or anything like that. The idea is that your car wants to stop before it hits the bunny, and the distance that you travel before you stop is called the stopping distance, and hopefully the stopping distance is shorter than the distance between the car and the bunny. Now, the stopping distance is made up of two parts. The first part is the thinking distance. That's the time from the distance that you travel from the time between you see the bunny, between the bunny appears and the driver puts his foot on the brakes. The second part is the braking distance. That's from when the driver puts his foot on the brakes to when the car actually comes to a stop. So the stopping distance is the thinking distance plus the braking distance. Now, you need to know the factors that affect these two distances, and the first factor that affects both of them is the speed of the car. The thinking distance, your kind of reaction time between you actually putting your foot on the brake. The faster you are traveling, the further you will travel in that same time. For the braking distance, the faster the car is traveling, the longer it will take for it to brake. Now, this is a graph that shows the speed versus the stopping distance. As you can see, it increases slowly at first, but then more rapidly. At higher speeds, the stopping distance rapidly increases. And these values are not proportional, but you need to have an understanding, be able to describe this sort of graph. Now, at 20 miles per hour, your stopping distance could be 12 meters. 30 miles per hour, 23 meters, 70 miles per hour, a whopping 96 meters. So if you're traveling along the motorway at 70 miles per hour and a tree falls down, you better hope the tree is further than 96 meters away, otherwise you are not going to be able to stop in time. You need to have an awareness of these figures because they might ask you to give rough values for these things. Now, back to thinking distance. So speed affects the thinking distance, and that's because you will travel a further distance if you are traveling faster in the time it takes for you to react to the danger. Your reaction time is between 0.2 and 0.9 seconds. This value, you need to know it. It's given on the specification, and that is average reaction times. You need to have an awareness of how you test for reaction times. You probably did that in biology with the ruler drop experiment, where somebody holds a ruler, or somebody holds their hand near a ruler, somebody else lets it go, and then you can see how long it took for them to catch the ruler. Reaction time is affected by tiredness, drugs, alcohol, distractions. There are more, but those are the 4 on the specification that you need to know about. The braking distance, as well as being affected by speed, is affected by adverse road or weather conditions. Adverse just means unfavourable or unfortunate or bad. And the 2 that the AQA want you to know about is if it's wet or if it's icy. Obviously, that reduces the friction, which means the car will travel a longer distance. Poor conditions of vehicles is another factor that affects the braking distance, and that is limited to the brakes, poor brake qualities, and poor tyre qualities. There may be other things, but these are the only things in blue and red that you need to know about. Now, you need to have an understanding of the mechanism by which a car stops. Cars use disc brakes, which is a sort of soft pad that presses tightly against a metal disc when the car wants to brake, and it is the force of friction that causes a car to brake. The disc brake essentially turns kinetic energy of the vehicle into thermal energy, so the disc brakes get hot when the car is braking. Now, a problem with disc brakes is that if there is a very large deceleration, so say you're stopping you're at 70 miles per hour and you need to stop, there are 2 problems that you need to know about. The first one is that the brakes will overheat, and the second problem is that you will lose control of the car, or you might cause loss of control. These 2 problems you need to know about. Now, you also need to know a rough value of this braking force, right? And you can calculate that using, and often hard questions come up where they ask you to calculate that. If you know the deceleration of a car, say 31 meters per second, we know the stopping distance is 96 meters. We can use v squared minus u squared as 2as, one of the equations on your physics equation sheet, to get a value for acceleration there of 5 meters per second squared. You need to have a general knowledge. A car mass is between 1,000 and 2,000 kilograms. And we can then use force is mass times acceleration to calculate a value for the braking force, the mass being 1,500 kilograms, the acceleration being 5 meters per second squared, or -5 deceleration, gives you a rough braking force of 7,500 newtons. And that's a value that you need to know the ballpark figure of. That's it.